Everyday refineries across the United States and around the world use a process called alkylation to produce cleaner gasoline for today's higher efficiency vehicles. This is an alkylation unit where that process occurs. Inside, a catalyst called hydrofluoric acid, or HF, is used to start a chemical reaction to produce liquid alkylate from light gases. Alkylate is high in octane, yet low in sulfur, evaporative emissions, and fuel volatility, which in the end helps lower vehicle emissions. There is risk involved in nearly every industrial process, including those that use HF. The way American refiners manage this risk sets us apart from every other industry. As manufacturers, safety and reliability are among the most important objectives for every refiner. In addition to being a highly regulated industry, we have operations teams and multiple layers of protective safety systems monitoring our HF units, as well as other measures that keep our workforce and host communities safe. Each refinery is unique, and so is every HF alkylation unit. It's because of that each refiner uses different combinations of protective systems to safeguard their HF units and personnel. The raw materials and the size and the configuration of the alkylation unit are all factors that come into play in selecting the safety systems, the protective gear, the tools, and the training provided to employees. Having proper protections in place best positions a facility to prevent, quickly detect, and immediately contain any possible HF release, however unlikely that may be. There are three protective strategies for HF safety: prevention, detection, and containment. We prevent incidents from occurring by rigorously training our process engineers and operators before they ever even step foot onto an alkylation unit. And then, after they qualify for the position, we provide them with ongoing training to ensure that they have the latest knowledge and skills. Trained and highly qualified operators monitor HF units 24 hours a day. They use safety technologies and practices developed by industry to operate their units reliably and prevent incidents. For example, per the HF Alkylation Industry Standard API Recommended Practice 751, the pumps used throughout the unit are required to have secondary seals to provide twice the protective barrier of typical refinery process pumps. Operations teams closely monitor pressures, temperatures, pipe and vessel thickness, and flows even in every piece of equipment in the unit. Following API's RP 751, refineries conduct routine mechanical and integrity inspections to identify issues and prevent them from becoming incidents. Early detection is so important in the unlikely event of a leak. Among other tools, refineries stage different types of monitors in and around the HF unit to alert operators in real time that they need to respond following established procedures. Monitors typically include highly sensitive perimeter lasers, point sensors, chemical spot detectors, as well as cameras throughout the unit that provide visual verification. This equipment can detect trace amounts of HF and will trigger visual and audible alarms on the unit and in the central control facilities where the unit is monitored remotely. We even apply a special paint around pipe connections that changes color to indicate that the slightest leak has occurred so that an operator can intervene to prevent an incident. Containment is the last piece in the response. Depending on circumstances, the unit's safety systems can be used to automatically trigger multiple devices to contain any escaped material, isolate the HF and equipment, or shut down even the entire alkylation unit. Operators assigned to the unit and in the central control routinely train using different scenarios so that they know what to do in moments like these. In addition to the automatic systems, the operations teams can respond within seconds to engage other appropriate safety systems, such as activating isolation valves to move the HF to a secure vessel where it is contained away from the unit to keep themselves, their team, and anyone in the surrounding area safe. All of the HF in the unit can actually be transferred and isolated within minutes. Another important factor is HF is soluble in water, and it can be rapidly absorbed when it comes into contact with water sprays. For this reason, refineries employ a variety of water mitigation tools on HF units, including water cannons and turrets, water walls and curtains in their deluge systems, each designed to produce the correct water droplet size that will most effectively knock HF vapor out of the air. Water used in this process is then collected on site and thoroughly treated to eliminate the risk of any contamination. Then refineries test their water mitigation systems regularly so they can depend on these. They're confident that these tools will work when and if there is ever a need to use them. So together, prevention, detection, and containment provide additional layers of security in and around the HF unit. These systems and the expert teams trained to use them are the reason why there's a long record of safe, responsible use of HF in our industry and why our country leads the world in producing clean fuels. Incidents both in the plant and off-site involving HF alkylation units worldwide are exceptionally rare. Our job as an industry is to make sure that continues, which is why API's RP751 is updated routinely based on learnings and input from experts who work full-time on HF alkylation units. Refiners are constantly reviewing and improving HF systems, tools, and operating practices to ensure we have the best science and technical data and resources to do our jobs safely. That's because the safety of employees and neighboring communities where we live, work, send our kids, and even our grandkids to school is the most important part of our work.